Okay, now we're going to start topic 1.4, quadratic applications. The drawing below represents the path of an object that's thrown into the air. If you notice, it's the shape of a parabola, and that is a quadratic equation. So what we're looking for, and remember the top part up here is called the vertex. The x-axis is usually represented by the ground in a word problem that describes height. Your height is your vertical distance, and the ground is usually remember, the solutions of the quadratic equation. Okay, I got the first one started. I kind of worked this one out ahead of time, but I'll show you how I did it. The path of the ball that's thrown upwards can be described by the equation h equals 35t minus 5t squared, where h is the height of the ball in meters and t is the time in seconds. On this first one, go ahead and change that. That should say high. On part A, it says how high is the ball after 3 seconds. Now remember, the seconds is the t in your equation. So what I did was I replaced the t I used 3 to replace the t, and I just worked out the height, and I let the calculator do it for me, and 35 times 3 minus 3 squared was 60. So 60 meters is the height after 3 seconds. Okay, on the next one, it wants to know seconds, and it's giving you 50 meters high. So you want to figure out after how many seconds is it 50 meters. Let me show you how you can do that in the calculator. Go into y equals and type in the equation, not the 50, but just type in the 35, and we'll use x instead of t. So 35x minus 5x squared. Okay, I want you to notice, let me move this up. What we want to know is when is this number, what number is this x when the answer is 50. So go to your table and see if you can find it. There's one. And this time there are 2 answers. So 2, it's at 50, and look, 5, it's at 50. There's a 50 on the 5 and the 2. So those are the 2 seconds. 2 seconds, it's at 50 meters, and 5 seconds, it's at 50 meters. Now you could use the quadratic equation for this one. I think I will show you that real quickly. I just wanted to show the calculator method because it's a little bit easier. But let's do the quadratic just to review. Remember, quadratic equation needs to be in standard form, so you'll know the a, the b, and the c. This one's not in standard form. We have to move both of these terms on the right side of this equation. To bring a negative to the other side, it becomes positive. To bring a positive to the other side of the equal sign, it becomes negative. So on this one, this would be your quadratic equation. Now this is your a and your b and your c. So let's see if we get let's make sure we get the same answer. X is always equal to the opposite of your b term, so I'm going to make that 35 plus or minus the square root of your b term squared minus 4 times your a term, your a value, and then times your c value. And you always divide that by 2 times your a value. I'm going to go ahead and multiply 2 times the a value would be, or the a would be 10. So that would be x equals 10. Divide by 10. Let's use the calculator for a moment to put in the radicand under here. Don't forget to put the negative number. If you're ever squaring a negative and you want your calculator to do it correctly, you do need to put it in parentheses. So we get 225. So the square root of 225 is 15. So you're going to take 35 and add 15, and then divide that answer by 10, and you're going to take 35 and subtract 15 and divide that difference by 10. When you take 35 and add 15 divided by 10, this answer's 5. If you do 35 minus 15 divided by 10, this answer's 2. Remember, those were our two answers that I first got when we put it in the calculator. So you really can use either method if you want to use the quadratic formula, or the first way we did it, we just put this part in the calculator. Let me draw a little graph so you'll remember that. We put this in the calculator, and when we saw the calculator had a 2, the y was 50, and at 5 the y was 50. So this method right here is the calculator method. This one over here is the quadratic formula, and you can choose which one you want to use. Okay, C says, when will the ball hit the ground? Remember, the ground is the x-axis. So let's go back. I've kept it in y equals, and I put in this equation, so let's graph this. Alright, we can't really tell in the calculator how high it went, but we can see where it's hitting the ground. And if you want to go into the table, let's draw our table on this. I'll draw a little T-chart. What you're looking for, or when the height is 0, because when your height is 0, that means it's hitting the ground. So these are your the two zeros, or the two solutions, are the ones you want to find. So on this one, let's go into the table, and if you notice, 7 is one of your answers, and I'll go up a little bit. Here's the other answer, 0. So 0, 0, and 7, 0. Well, when will the ball hit the ground? 7, 0, the one you want to choose, because 0, 0 means it hasn't actually left yet. The ball that was hit hasn't left the ground, so this one's your answer right here. 7 seconds. Okay. On page 2, we have another equation that's talking about an archer shooting an arrow into the air. This equation is different. It's 17t minus 5t squared, where h is the height again and t is the seconds. So just be careful when they're asking seconds and they're giving you, when they're asking how high and they're giving you the seconds, your t is 2 on this one. So let's go do that one the way we did the first one. Go to your y equals and type in your quadratic equation. This time it's 17, and remember, in the calculator you can use the x instead of the t, minus 5x squared. Okay, we're looking for oh, this one's the 2. Okay, this is a way you can do it. If you want the x to be 2, then go into your table. If you type this in y equals, look at the table. When x is 2, the y is 14. So the answer on this one would be a height of 14 meters. Now that's using the calculator. If you wanted to do it by hand, you remember you do replace your t with a 2. So there's the way you could do it if you were replacing it. I just let the calculator do it. Alright, on the next one they want to know, when will the arrow be 10 meters high? On this one, if you look at the calculator, if you look at the table, it goes from 1 to 12 and then 2 to 14. So we know it's somewhere in between the 1 and the 12. Let me kind of show you a way you can do this with the calculator. If you go to y2 and you type in, I want to know when y is 10, and then you push graph, what's going to happen is it's going to draw a horizontal line, and it's kind of hard to see right here because the window's set to just go up to 10, so you might want to change your window. Let's go a little bit higher, maybe 20, and graph it. Okay, look at the path of this quadratic equation. The first thing that was drawn was the parabola. That's the 17x minus 5x squared. And when I put the 10 in, it went here. It's going to show you where it intersects, right here and here. It might be best if I guess we could find the intersection. Let's see if that works. Second trace, number 5. My first curve is the parabola. My second curve is that one. So the intersection point looks like it's 0.75 on this side. Let's write that down. 0.75. That's one of the times, 0.75 seconds when it's that high. Now let's see if we can let it do the other one. We're going to intersect. This time I'm going to go to this side of the curve. Yep, it did do it. The other one is at 2.6. So around, these are your two answers. Around 0.75 and around 2.6. Those are your two seconds that the arrow is 10 meters high. Now if you wanted to use the quadratic formula on that one, you could too. Just remember, you're going to replace, let me just show you how you would do that. You're going to replace your h. Let's rewrite the formula right here so you'll understand. You'll replace the h with 17, you're going to replace the h with 10. 17t minus 5t squared. Now remember, to use the quadratic formula like we did on the page before this one, you have to set it equal to 0. So if you bring the t squared term to the other side, it becomes positive. You bring the t term to the left side, it becomes negative. The 10's already on that side, so keep it positive. And here's your a and your b and your c, and you could do the quadratic formula. I just kind of wanted to show you a method to do it in the calculator. But about 0.75 seconds, and again at 2.6 seconds. So you got to think about the arrows going up and then coming back down. So there's 2 times that it's going to be 10 meters high, and that's shown on this graph. Let me review for a second. When I put in y equals 10, that drew this horizontal line right here, and it's going to show you, if you think about this, just this side, the arrow moving up and coming back down, there are 2 different times that it's going to be 10 meters high. And they were not exact answers, but we can use quadratic formula or the intersection point to help us find that. Okay, let's go on to part C here. When will it be 20 meters high? Okay, I want you to notice something. Let's just try this. Let's go to the table for a minute. Let me take off the 10 meters high. Actually, you know what? We could do 20. Let's change that y equals 10 to y equals 20. So right here I changed it to a 20. If you push graph, first it's going to draw the parabola, and then it's going to do the 20. And I don't know if you remember, but I changed the window to 20. Let's go a little bit higher. I think I'll change the y maximum to 25. If I changed it to 25 and push graph, you'll see the y equals 20 line a little bit better. Okay, see this horizontal line that's going across at 20? That means the arrow never gets that high. So you need to realize that sometimes they're going to ask a question that it's just not going to happen. It will never get that high. Okay. Alright, here's a question that we were asked last time. When it hits the ground, remember that means at the x-axis. So if you want to think about the table, it actually means when your height is 0. And remember, we're letting our y, instead of h equals, let's write the equation again. H equals 17t minus 5t squared. And remember, our height is our 0. We want to know when is it 0. So it's still in my calculator. So let's go to the table. Let me take out the 20. I guess you could put it at 0. We could try that. Alright, it's going to hit at, I think this one does go to 0, 0. Let's go see. Yes. So one of our starting point, this just means where it starts. So that's really back to the ground would mean after it's gone in the air for a while. So you kind of want to figure out when it goes back to the ground. Now look at the table here. Does it make sense that because 3 is at 6 meters high and then 4 is at negative 12, that it's going to hit the ground somewhere between 3 and 4 seconds? So that's kind of a hint on where this one's going to be. Now let's push second trace and then number 2 because it's a 0 and push enter. I think I'm going to try to zoom in and see if this will... Oh wait, that's zoom out. Just a minute. Let me zoom it in. Okay, that might be a little bit better. When you push second trace, this is the picture, and right now it's blinking at 0, 0, but we really want to know exactly where this one is. So when we push second trace, number 2, when it's asking for the left bound, it means the left side of the one we want to find. So let's just move it, and left would be above the line. Move it to below the line to be on the right bound. When it says guess, you don't have to worry about that one, just skip that one. Now notice that it tells me exactly the x value when y is 0. So at 3.4 seconds the height is 0 meters. That means that's where it hits the ground. So 3.40 means 3.4 seconds at 0 meters. This was our seconds and this is our meters when we're using the calculator. You could also use quadratic formula, just let your h be 0. So if you did want to plug this in the quadratic formula, just make sure you're only this time going to use an a and a b. You wouldn't have a c in the quadratic formula. Okay. The last one in this section, number 3. Let's read the question. The area of a rectangular piece of cardboard is represented by the equation W times the quantity 2W plus 3 equals 9, where W is the width of the cardboard in feet, and they want us to find the width. Okay, this will make a quadratic equation. I think I'll rewrite it for a minute to show you that. You need to use the you need to use the distributive property to multiply. So 2w times w would be 2w squared, and then a w times 3 would be 3w. That removes your parentheses and you should notice that now that it has a squared variable that it is going to be a quadratic equation. So on this one, let's set it equal to 0. And so we're going to leave 2w squared plus 3w minus 9 equals 0 because we're bringing a 9 that's positive on the right side. We're bringing it to the left side, so we're subtracting it on both sides. That's why you need to set it equal to 0. Now we're going to solve this quadratic. I think I'll just go ahead and use the quadratic formula, and then maybe we'll check it in the calculator in a minute. Let's go ahead and do that. So x is equal to the opposite of your b term plus or minus the square root of your b term minus 4 times a times c, all divided by 2 times your a term. So that'll be 2 times 2. So x would equal negative 3 plus or minus, let's go ahead and figure out what this radical is. I'm going to use my calculator. I'll let you see it. Alright, 3 squared minus 4 times 2 times negative 9. Okay, that's 81. So 81 is a perfect square root. The square root of 81 is 9. So when you work this one, you're going to do negative 3 plus 9 divided by 4 and negative 3 minus 9 divided by 4. And please remember, if you're doing this in the calculator, you need to push enter before you divide by 4, or put it in parentheses, however you want to do it. But just make sure your calculator is adding and subtracting before it divides. So let's do that. I like to show it to you, so let me do that. Negative 3 plus 9 divided by 4 is 1.5. Negative 3 minus 9 divided by 4 is a negative 3. So remember, the question wanted to know what the width was. And since the width can't be negative, let's write that on here. The width cannot be negative. So don't pick that one, especially in a word problem. You want to pick the one that's going to be the positive answer. So 1.5 is the correct answer to this one. I think I'll show you how to put this one in the calculator. Let's move this out of the way. I'm going to go back into my y equals, and I'm going to type in the equation when it was solved for 0. So we're going to take this one. This is really the one you want to put in the calculator. So let's try that. 2x squared plus 3x minus 9. I'm going to push graph and see what happens. Okay. For you to understand this one, if you'll remember our two answers, we had a negative 3. Let me make sure I typed it in right. 2x squared plus, yeah. We had a negative 3. I'll just show you that one. See, negative 3 is at 0. And then the reason 1.5 is not on here is because it's only going by ones. So if you want to go in and reset the table, you could start it at 1.5, and I'll show you it'll go to it. See how it says 1.50. Another way to do that is push second trace, push enter. Let's see how it's blinking at the value for x. Put in 1.5 and push enter, and it should tell you what the y is. So 1.5 is the correct answer. Okay, good luck.